So I'm very happy to present this paper, which is co-authored work with Simon Glaise, who's at PSC in this conference. So as Robinson said, feel free to ask like clarification questions or like any kinds of questions in the chat. I have a very hard time following the chat when I'm showing my screen, so it'd be great if like someone could cut me off and read the questions for me if the questions rise. Great, thank you. So what we start from in this paper is the idea that institutions in place in a society shape agents' incentives to gather information. So the institutions in place are going to shape how much information agents want to acquire and what kind of information they want to acquire. So an example of this would be a good allocation setting. So in such a setting, it's very likely that the specific auction mechanism that is used to allocate the good is going to impact how much bidders want to invest resources to learn their valuations for the good. So here I want you to think of a setting in which agents are not fully informed ex ante about their valuations for the good, but can actually invest additional resources learning about their valuations. And then the auction mechanisms is likely to have an impact on these sorts of incentives. So an extreme example would be if you use very arbitrary auction mechanisms that just allocates randomly the good to agents, then bidders would have absolutely no incentives to acquire information. But if you use a more flexible mechanism, such as a second price auction, then since bidders have some choice in the matter, they actually have some incentives to learn. So what we investigate in the paper are the following questions. First, we want to understand which mechanisms lead to simple informational incentives. And I'll be more precise as what I mean by simple on the next slide. And then we want to understand how these simple informational incentives actually matter for the design of institutions in practice. So what do I mean by informational simplicity? So throughout this paper, we're going to be thinking of informational simplicity as the requirement that players only have an incentives to learn about their own preferences, but not about other people's preferences. So for instance, in an auction setting, an equilibrium is informationally simple if bidders only acquire information on their own valuations for the good, but not on other bidders' valuations for the good. So here I want you to think about a setting in which my preferences for the good are pinned down by the realization of some fundamental. Your preferences for the good are pinned down by the realization of another fundamental. So these two fundamentals are distinct. And we want to understand in what kind of situation I would have an incentive to only learn about the realization of my own fundamental, so only acquire information on my own valuation. So why are we looking at this specific notion of informational simplicity? One reason is that it actually endogenizes an independent private value property, which is often assumed, especially in auction settings, on the interim information structure. So in our model, the information structure that arises is endogenous. It's going to be the result of this information acquisition stage that takes place before agents enter the mechanism. And we're going to show that this endogenous information structure satisfies this independent private value property only if the mechanism satisfies this informational simplicity requirement. So our main result is actually a mostly negative result. So what we show is that under some assumptions on the cost of information, and these are going to be the most important assumptions in our paper, a static mechanism is informationally simple only if it is dictatorial. So in particular, even non-dictatorial strategy-proof mechanisms, such as a second price auction or the deferred acceptance mechanism in a school choice setting, can lead agents to want to not only acquire information on their own preferences, but also on other agents' preferences, despite the fact that these mechanisms are actually strategy-proof. So what is the intuition for this? So the intuition is that other agents' preferences under a non-dictatorial mechanism are going to impact the report they're going to send to the designer. And through the mechanism, they're going to impact my choice set. So my choice set is the set of outcome I can bring about under the mechanism. And the value of information on my own preferences very much depends on my choice set. If I'm facing a large choice set, then information on the different options is actually valuable. If I'm facing a very small choice set, or in the extreme case, if I'm facing a singleton choice set, then I literally have no choice, and then information is actually completely useless to me. And so endogenously, through the mechanism, other people's preferences impact impact the value of information on my own preferences for me. And hence in equilibrium, it's going to be often optimal for me to first learn about other people's preferences, because that tells me how much resources I should spend learning about my own preferences. So that's the high level intuition for the result that even strategy proof mechanisms may provide incentives for agents to not only acquire information on themselves, but also on other agents in the economy. So we have this mostly negative result, and we want to understand what sort of implications it has for mechanism design. A first implication is that even strategy proof mechanisms are complex in the following sense. So usually in mechanism design, we like strategy proof mechanisms because they are easy in the sense that agents then have a dominant strategy. What we show is that for a mechanism to actually be strategy proof in this extended game that includes this information acquisition stage ex ante, it has to be informationally simple. So agents are going to have a dominant strategy in the information acquisition stage if and only if the mechanism is informationally simple, and hence if and only if they don't have an incentive to learn about other people. And because we have our impossibility result, this is going to be virtually impossible unless you're actually using a very trivial dictatorial mechanism. Another implication is that because agents are almost always going to acquire information on each other, their private information, so their types upon entering the mechanism, are generally going to be correlated. So this is mostly what I'm going to be talking about today. But before I dig into the formal model, I want to go through a simple auction example, which is hopefully going to give you all the intuition underlying the main results. So in this auction example, we'll be thinking of a seller, the county of Santa Clara, who is selling a good. So here the good is going to be a piece of land using a second price auction. There are two potential bidders in this auction, a shopping center and an oil company. And importantly, both bidders have uncertainty regarding their valuations for the good, so valuations for the land. The shopping center's valuation for the land depends on demand. And demand is either high or low. So theta I is going to be the random variable that determines the value of demand, and it can take on two possible values. And similarly, the oil company's valuation for the land depends on whether or not there is a lot of oil in the ground. And this is captured by the theta j random variable that again can take on two possible values. And ex ante, the realization of these random variables is unknown. Importantly, we assume that the shopping center only cares about demand and the oil company only cares about oil. So the valuations for the land in state theta for the shopping center only depends on the realization of demand. So if demand is low, it's 0, irrespective of whether or not there is oil in the ground. And if it's high, it's 20. And similarly, the valuation for the land for the oil company only depends on the realization of theta j, only depends on the amount of oil in the ground, but is independent of demand. So it's high if there is a lot of oil in the ground, and it's fairly low. It's 10 if there is just a little bit of oil in the ground. So the underlying preferences, valuations for the good of these two bidders are private and independent. Agents all share common prior belief over these 4 possible states of the world, and they think ex ante that they are all equally likely. The timing of the game is as follows. So before entering the auction, bidders can privately acquire costly information on any state. So independently, for instance, the shopping center could decide to learn about the realization of demand, but if it wants to, it could also decide to learn about the realization of the amount of oil in the ground. And then once they've acquired some information, bidders are going to be submitting bids, and then the second price auction is run. So again, the second price auction is usually strategy proof. And here we want to understand whether bidders have an incentive to acquire information on others. So for instance, does the shopping center have an incentive to acquire information on the realization of theta j, on whether or not there is oil in the ground, even though his valuation for the good does not depend on this fundamental. And what I want to convince you of is that the answer to that question is yes. So why is that true? So take the perspective of the shopping center, so of bidder I, and think of all the states of the world in which there is a lot of oil in the ground. So theta j is equal to theta jh. Then in all these states of the world, it's very likely in equilibrium that the oil company is going to learn that there is a lot of oil in the ground and is going to submit a very high bid, which is always going to be the winning bid. And then in that case, learning about the state of demand for the shopping center is useless because it's never going to win the auction anyway. On the contrary, if in all the states where the amount of oil in the ground is fairly low, again, it's likely that in equilibrium, the oil company learns about this and submits a fairly low bid. And then in these states, it's going to be useful for the shopping center to learn about demand, because if demand is low, it doesn't want to win the auction. But if demand is high, it would get a strictly positive payoff from winning the auction. So overall, the value of information on his own valuation, the value of information on demand for the shopping center, depends on the presence of oil in the ground, depends on theta j. And hence in equilibrium, it's going to be optimal for, under some conditions on the cost of information, for the shopping center to first learn about the realization of theta j before learning about the realization of demand of theta I. So what I want you to take away from this example is that even strategy-proof mechanisms like BCG are not informationally simple and may incentivize agents to not only acquire information on their own valuations, but also on other bidders' valuations. Of course, whether this actually happens in equilibrium or not is going to depend a lot on what kind of assumptions we have on the cost of information. So in the extreme case, for instance, in which it's arbitrarily costlier to acquire information on others as opposed to just acquiring information on yourself, of course, you won't do it. But what we're going to be thinking about throughout this project is situations in which the cost function is actually smooth. So the cost of information is going to be smooth, such that you're going to want to learn more when the value of information is higher in equilibrium. And because the value of information for you depends on other people's preferences, in equilibrium, you're going to want to learn about other people as well, unless the mechanism is dictatorial. This intuition that the value of information for an agent depends on others' reports is generically true. So our result is going to be a generosity result. And it does not depend on the specific numbers we chose for the previous example. Okay, so this is kind of the big picture of the paper. I don't want to go through the literature in much details. What I want to say, though, is that there are a few papers that look at mechanism design with information acquisition ex ante. Many of these papers consider a setting with only a single agent. And the few papers that actually look at a multi-agent setting, they usually assume that agents can only acquire information on their own underlying state. So this is clearly where we deviate from the literature. We actually allow agents to acquire information on anything they want to. And we want to understand in what kind of situations they would actually only want to learn about themselves. Okay, so what I'm going to do next is go through the formal model, define informational simplicity a bit more formally, and then show you the main negative result. And then I'll go through some implications of this negative result for mechanism design. And finally, I'll discuss and conclude. Okay, so the model. So the setup is very standard. We'll be thinking about good allocation problems. So we'll be looking at a single good that needs to be allocated. This is really for the sake of clarity and ease of exposition. The result easily extends to settings with multiple goods. It also extends to a setting with some abstract set of outcomes. But here we'll just think of the allocation of a single good. There are n possible agents with unique demand for the good. But importantly, these agents have uncertainty regarding their valuations, their preferences for the good. And we're going to be modeling this uncertainty in the standard way. So each agent's preferences is going to be pinned down by the realization of a random variable theta I. So capital theta I is the set of possible states for an agent. And then the overall state space is the cross product of all these individual specific state spaces. And then each agent has a utility function, which gives for every possible realization of this state a utility value for the good. So importantly, the preferences for agent I over the good only depends on theta I. It does not depend on theta minus I. A mechanism is, as usual, going to be composed of a set of messages for each agent. So MI could be the set of bits that I can submit to the designer. Some allocation function xi, which takes as input a profile of messages and gives i's allocation. So it's i's probability of getting the good. And then transfer functions. So again, taking as input a profile of messages and then giving as output the price that agent I has to pay. Agents' preferences are quasi-linear. So the utility of an agent I under a message profile M in state theta is going to be equal to the probability she gets the good times her utility value from the good in that state, which only depends on the dimension I of the state, minus the price she pays. So far, this is a very standard problem. And now this is where we deviate from the standard model because we're going to be making the information structure endogenous. So we're going to be starting from a common prior at a node on all the possible states of the world that is shared by all the agents in the economy. And we'll be assuming that this prior belief satisfies independence. So this is abusing notation a bit, but the underlying valuations of agents for the goods are independently distributed. And this is like a strong assumption, but this is actually an assumption that is made just to make our impossibility results stronger. And if we don't make this assumption, our research question doesn't even make sense. So if valuations for the good were to be correlated ex ante, then it would be actually impossible for me to just learn about my own valuation, because upon learning something about theta I could update my belief about your valuations as well. So to make it feasible for agents to only learn about themselves, we assume that their underlying valuations are independently distributed. So it would actually be feasible for me to only learn about the realization of theta I. So in this setting, we want to allow agents to acquire additional information. And we'll be modeling this as agents being able to buy a signal. So signal x tilde is just some random variable that can be arbitrarily correlated with the state theta. And if agents can choose from a sufficiently rich set of signals, it has been shown in the literature that this is equivalent to choosing a distribution of a posterior beliefs pi I. Why is this true? Well, any signal that you choose is going to induce some distribution of a posterior beliefs, because upon observing a realization, you're going to update your belief. And what turns out to be true is also the reverse. So any distribution of a posterior beliefs that satisfies some base plausibility condition can be induced by a signal that is appropriately chosen. So we'll be using this term signal and distribution of a posteriors interchangeably. To make things non-trivial, information is costly, and C is the cost of information that takes as input a signal or a distribution of a posteriors and gives as output the cost of that signal. And the key assumptions in our model are going to be the assumptions we put on this cost function C. And these are the assumptions I'm going to go through now. So the first assumptions we put is what the literature has called posterior separability. And it is quite a bit of a mouthful, but it is quite intuitive. It says that the cost of a signal or a distribution of a beliefs is equal to the expected reduction in some measure of uncertainty. So H is some measure of uncertainty, which is strictly concave. So it gives for a possible belief, the uncertainty in that belief. And then the cost of a signal is going to be equal to the the uncertainty in your prior belief minus the expected uncertainty of your posterior belief. So if in expectation, your posterior belief is very precise, this term is very low, and the cost of the signal is very high because the signal is informative. So this seems restrictive. It is. There is actually a nice characterization of such cost functions, but importantly, I actually don't think we need that assumption for our results. And we're in the process of relaxing it. We're in the process of revising the papers. So like all comments are very welcome. And in particular, this is one assumption where we're relaxing. What this assumption does is that, for instance, it rules out the possibility that learning about others is infinitely costly and unfeasible. Now, these are the key assumptions that I don't think we can relax very easily. So the first one is some sort of innata condition that says that as you're becoming fully informed, the cost of additional information becomes infinitely costly. And what this gives us is that in equilibrium, agents are never going to choose to become fully informed, and we can rule out this corner solution. The other condition is that the cost of information is smooth. It's twice continuously differentiable on the interior of of the simplex. And what that means is that in particular, there is no kink in the marginal cost of information if you start learning about other people. So this is going to be important to get our main results. So in the paper, we actually start introducing, we have a section where we introduce fixed cost when you start learning about others, and we see what kind of impact this has on our results. But I'm not planning on going through this in the talk, but if you have questions about this, I'm happy to answer them. So for the talk, just think of the cost function as something very smooth, no discontinuity, no kinks. Okay, so in these settings, agents have to choose two kinds of strategies: an information strategy, so the choice of a signal, and a reporting strategy. So given your posterior belief, what message do you send to the designer? And the timing of the game is as follows. At the beginning, the state is drawn, and the designer commits to some mechanism. Then agents decide what information to acquire. They update their beliefs. Given their new posterior beliefs, they send a message to the designer. They submit some bid. And then the mechanism is run and some allocation is induced. And standard definition of a Nash equilibrium, it's a strategy profile such that every agent is maximizing his expected utility, given that others are following the equilibrium strategy. So here, the only important thing to note is that the choice of a signal of a distribution of a posterior per I is valuable because it allows agents to, information is valuable because it allows agents to send the correct message, the correct bid more often in every state of the world. But information comes at a cost, and this is the key trade-off that agents face when they decide what information to acquire. Okay, so this is the basic setup, and now we can start talking about informational simplicity. So again, in the introduction, I said informally that informational simplicity would be the requirement that agents only want to learn about themselves. So formally, an informationally simple equilibrium is an equilibrium in which each agent chooses a signal that is independent of other people's valuations. So the signal chosen by agent I is independent of theta minus I. So it's a refinement of, yes.
I'm sorry to interrupt, Agathe. Can you go back to the definition of equilibrium for a second?
Yes.
Is there an implicit assumption about not only the strategic behavior of your opponent, but the information acquisition behavior of your opponent in this definition of equilibrium? Does it say, given they are requiring information, you play best response to that, or is that irrelevant and the stupid question?
No, that is definitely relevant. It is not a stupid question. And yes, they are also best responding to the information strategy of their opponents. So the information strategy of their opponents, if you can see my cursor, is this P minus I star. So it does enter their expected utility, and they are best responding to this as well.
And would things be different if they were myopic with respect to that?
Yes, yes, yes.
Okay.
It would be different.
Thank you.
Thanks for the clarification question. So an informationally simple equilibrium is a refinement where agents only learn about themselves. Why do we care? It captures some notion of simplicity, and I'll go back to this later. As I said in the introduction, it relates to the assumption of independent private types. So in a standard mechanism design problem, a type is an agent's private information. So it's the belief when they enter the mechanism, and it's usually assumed to be exogenous. In our model, the type is endogenous. It's the result of this information acquisition stage. And what we show is that agents' types, their belief upon entering the mechanism, are going to be independent if and only if the equilibrium is informationally simple. And intuitively, you can think of this in the following way. If the equilibrium is not simple, then I'm learning something about someone else, and that other person is also learning about themselves. So we're learning about the same objects, and hence our beliefs when we enter the mechanisms are going to be correlated through this underlying state that we are learning about, both of us. Okay, so the main question of the paper is which mechanisms admit an informationally simple equilibrium. This is the last definition, I swear, before the main result. So a mechanism is dictatorial over some set of message profiles if there exists at most one agent who can influence the outcome. And formally, an agent can influence the outcome if by just changing his report. So if agent I can influence the outcome, if by changing his report from some MI to another message MI prime, keeping fixed the report of other agents, the outcome changes. So here only agent I is changing his report to the designer, and this has an impact on the outcome. If you have at most one agent such that this is true, then we say that the mechanism is dictatorial. If more than one agent can influence the outcome, then the mechanism would be non-dictatorial. Okay, so here's the main results. So fix any cost function that satisfies the assumptions I described before. We have the following result. For a set of preferences that has full measure, so that the following result like holds in a generic sense, the following holds. If an equilibrium is informationally simple under the mechanism gamma, then the mechanism has to be dictatorial on the support of that equilibrium. So the mechanism has to be dictatorial over the set of messages that are actually sent in equilibrium. So it's like a small comment on this. This is technically not a statement on primitive because informational simplicity only requires the mechanism to be dictatorial over the set of messages that are actually sent in equilibrium. But another way to state this result would be to say that if you have an informationally simple equilibrium of gamma, then there is an outcome equivalent mechanism that is fully dictatorial. So in practice, it doesn't change much. It just says that if you want an informationally simple equilibrium, then in equilibrium, your mechanism is going to be dictatorial and it's only going to respond to the report of at most one agent. Yes.
5 minutes left.
Oh, okay, sorry. And the intuition is the same as in the motivating example. If the mechanism responds to the messages of two agents, then agents would have an incentive to learn about each other. If the mechanism only responds to the message of one agent, then that agent only has an incentive to learn about himself. Okay, I'll skip through that maybe, and so that I have time to go through the implications from mechanism design. So as I hinted towards in the introduction, informational simplicity relates to the notion of strategy proofness. And now I want to be a bit more precise as to what I mean by this here. So again, in a standard mechanism design setting, an agent's type, his belief upon entering the mechanism is exogenous, and we say that a mechanism is strategy proof if agents have a dominant strategy. Now, in our model, an agent strategy is also the choice of some signal to acquire in this information acquisition stage. And what we show is that for agents to have a dominant strategy in this extended game that includes this information acquisition stage, it has to be that the equilibrium is informationally simple. So in particular, if there is no informationally simple equilibrium, then it's impossible for agents to have a dominant strategy in this extended game. So formally, if you have an equilibrium in dominant strategy of gamma, then that equilibrium has to be informationally simple. And the intuition is the following. Suppose it's not the case. Suppose you do have an equilibrium in dominant strategy, and it is informationally simple. Well, it means that an agent is actually learning about someone else's preferences because it's not informationally simple. But again, in this setting, someone else's preferences are not directly payoff relevant to you. They only matter to you through the mechanism. So if you learn about someone else, it's only to predict their report to the designer. And hence, it can't be that you're learning about someone else in a dominant strategy way. It has to be that you're learning about someone else as a function of their strategy because what you're trying to predict is their report to the designer. So a dominant strategy can only be achieved by an informationally simple equilibrium. Okay, so let me try to give you some discussion of our main result. So again, our main result is mostly negative. There are a few ways you can approach the question to get a bit more positive results. One is to consider sequential mechanisms. So our result holds for static mechanisms, but if you start considering sequential mechanisms in which agents actually play in a sequence and can acquire information at any time throughout the mechanism, then you can actually achieve informational simplicity using a non-dictatorial mechanism. So an example of this would be a serial dictatorship. If you're using a serial dictatorship to allocate an object, then agents are allowed to acquire information at any stage, then that would actually be informationally simple because you would just wait for your turn to choose to acquire information, and then you would actually observe your choice set. So you wouldn't have to learn about other people's preferences to kind of predict your choice sets. Another way to get more positive results would be to consider a large market, because again, here you want to learn about others to predict their report to the designer. But if you're considering a large market with a continuum of agents, then there is no uncertainty about the distribution of reports to the designer, and these sort of incentives would go away. And the last way to get more positive results would be to start to relax the assumption on the cost functions, which we do in the paper. And for instance, to introduce a fixed cost to learning about others, because maybe learning about others is harder than learning about yourself, which is fair. In that kind of setting, we show that neither the existence nor the inexistence of an informationally simple equilibrium is going to be generic. So the results are less neat, but they still hold to some extent. I think I'm almost out of time, so I'll just conclude briefly. So our main result in this project is this impossibility, quote unquote, result that an informationally simple equilibrium exists only if the mechanism is dictatorial, and in particular, even strategy-proof mechanisms are going to induce agents to want to learn about other people and not just themselves. One implication is that even these strategy-proof mechanisms are going to be complex, and in the extended game that includes this information acquisition stage, agents virtually never have a dominant strategy in any non-dictatorial mechanisms. And another implication is that, as I said in the introduction, agents' private information is going to be correlated when they enter the mechanism. So often in auction theory, that means that you can then extract full surplus for them. In the paper, we actually investigate whether that is possible. And we actually show that it is not possible, because by the threat of extracting full surplus would actually distort incentives to acquire information ex ante. So we have these additional results in the paper. I didn't want to include it in the slides because lack of time, but happy to talk about this as well. I'll just stop here. So thank you for listening very much.